Okay, so in this video, I want to discuss the margin of error of these confidence intervals and how that's related to the size of the sample that you choose. And so if we continue with this thread of thinking about the survey that ABC News did, where out of 443 random adults that had left the house in the previous week, 244, 55% of that sample said that they had worn a face covering when they left the house. And we constructed a 95% confidence interval using different methods. And so the method I want to consider here is if, let's say we're doing it by hand using the Agresti-Cole confidence interval. We showed on the previous video that 95% Agresti-Cole confidence interval would go from 0.527 up to 0.574. And recall that for the Agresti-Cole confidence interval, our kind of point estimate is this p tilde, which in this case would be the 244 plus additional 2 successes out of the 443 plus an additional 4, right? So we assumed we had 4 additional trials, 2 of them were successes and 2 of them were failures, and then that's where this estimate came from. So if we first want to consider what's the margin of error in this estimate, then we would say our plug-in principal estimate, our kind of estimator initially was p tilde. And so what I'd want to know, for example, is p tilde plus or minus this margin of error. When I go plus, I should get this one, and when I go minus the margin of error, I should get that one. So for example, if I take the p tilde and subtract the 0.527, the lower estimate, that's going to give me an estimate for the margin of error. And that comes out to a little bit more than 2%, so it's 0.023. And you can check that if we were to subtract this from, or excuse me, if we were to add this to our p tilde, then that would give us the upper estimate. So for the Agresti-Cole 95% confidence interval, we had a margin of error of about 2.3 percentage points. Okay, so oftentimes when we're doing these calculations, we might have a target for our margin of error. So let's say I want to be really precise with my estimate, and I want at most my margin of error to be 1%. How large of a sample would I need to collect if I'm doing an Agresti-Cole confidence interval in order to reach that level of accuracy? So our margin of error, if we're using the Agresti-Cole confidence interval, right, would be 1.96 for 95% confidence interval times the standard error of the sampling distribution that we're estimating with this p tilde estimator. And so here, what I want to solve for is the unknown n tilde, right? And then I want to convert that to an actual sample size n. So I've got an equation here, and I know what to plug in for everything. For example, we want the margin of error to be 1%. Okay, and so that margin of error we can get using this formula over here. It's the 1.96 times our estimate for the standard error of the sampling distribution for the proportion when we use p tilde as the estimator. And we set this margin of error less than or equal to the 1%. And we've got our value for p tilde over here. So this gives us an inequality that we need to solve. So on the left side, we've got that the margin of error is 0.01, and we want that to be greater than or equal to our margin of error. 1.96 times our p tilde, and that's approximately 0.5503. Times 1 minus p tilde, all divided by n tilde. And so now we can solve that for n tilde, doing some algebra. And solving for n tilde, we get a value that n tilde needs to be greater than equal to 9,506.8. And therefore, n would need to be greater than equal to n tilde minus 4. So we need to subtract off those 4 extra values that we include in our sample. And so that would say that n needs to be bigger than 9,502.8. And here we can't have fractions of people. So regardless of what that decimal is, we would need to bump that up to the next greater integer. So here we had a 0.8, but we're not actually rounding up. We're just bumping it straight up. So even if I had a 0.1 as my decimal, I need to have a sample which is bigger than that. So I would pick the next biggest integer. So that's where the 9,503 came from. So to decrease the margin of error from a little bit more than 2% down to 1% means we would need to change our sample size from 443 all the way up to 9,503 people. And that's a lot of people to include in a survey. But at least that tells us what the benchmark would need to be if we wanted to reach that threshold of having a margin of error at most 1%. And so let me just say that in this example, we actually knew what p tilde was because we had a sample. So we have some prior knowledge of what I expect p to be. But let's say I'm setting out to do this survey, and I have no idea what to expect from my results. I don't know if it's 55% of the people that wear a face covering, 85% of the people, or 10% of the people. So in that case, if we don't know what p tilde is, well, how could we solve this inequality over here? So in those cases, we're going to err on the side of caution. So we're going to make our sample as large as we would need to be in the worst case scenario. And so in the worst case scenario is we would use a p tilde value of 0.5. So if we assume that our population is evenly split, that's going to create the most variability possible in our sampling distribution. And so if we pick a sample size large enough to account for that variation, it's going to be large enough to account for any value of p tilde that we would want to use. So in that case, you would just set up a very similar inequality here, and that is we would want this 1% to be greater than or equal to the 1.96 times the square root. And now in place of p tilde, we're going to use 0.5, and therefore 1 minus p tilde is also 0.5. And then we're going to divide all of that by n tilde, and you would solve that similarly. And so if we didn't have any prior knowledge of what to expect for our sample proportion, and I were to solve this equation instead, this would give me, you can check this, that n would in this case have to be greater than or equal to 9,600. So you can see that would be the worst case scenario. And so if you don't know what p hat is, if you don't know what to expect about your sample, then you would set up this calculation assuming that it was as variable as possible, meaning half the population was in one direction, half the other direction. And if I pick a sample that is this big, no matter what my sample proportion works out to be, my margin of error is definitely going to be less than 1%.